Hi, fifth graders. This video is for those of you who prefer to multiply using the area model. And remember, with an area model, you are multiplying by each different place value position. We can do that with decimal numbers, just like we did with whole numbers. So when we're multiplying using the area model, we could be solving a problem that's making equal groups, finding part of a group, finding part of a part, or resizing. So when we see decimal factors, for example, like 2 and 61/100ths times 7, the only difference is that we have to keep track of where the decimal point needs to go in our answer. So to do that right away, I would suggest counting the number of digits after the decimal point in each factor and writing that number in parentheses above the factors. So in 2 and 61/100ths, I see 2 digits after the decimal point, the 6 and the 1. But in my whole number 7, I don't have any digits after the decimal point. So I'll put a 2 above my first factor and a 0 above my second factor. Now, I'm going to pretend like the decimal point doesn't even exist in this problem. So to solve for the area model, I know that I'm going to put my 7 on the side. I'll break it into 260 and 1 because I'm going to pretend like that decimal point's not there. So that tells me I'll solve 7 times 200, then 7 times 60, and then 7 times 1. I know from multiplying whole numbers that what I need to do next is add together each of those pieces. So that means that if I was multiplying 261 times 7, my answer would have been 1,827. But I know it wasn't 261, it was 2 and 61/100ths. So now I need to use these numbers in parentheses that I wrote at the start of my problem in order to help me solve the decimal part of this question. So I'm going to add these two numbers together. In other words, 2 plus 0 equals 2. And what that answer tells me is how many places I need to move my decimal point in my final answer. So I'll start with thinking that the product is going to need to have 2 digits after the decimal point because 2 plus 0 is 2. So in the whole number 1,827, I know it has a decimal point on the end. So I'll shift that back 2 places for a total product of 18 and 27/100ths. And to check my work, I can think, well, 2 and 61/100ths is in between 2 and 3. 2 times 7 would be 14, and 3 times 7 is 21. So my answer should be between 14 and 21, and 18 and 27/100ths is. Let's take a look at another example. This time I have 2 decimal factors, 2 and 4/10ths times 1 and 8/10ths. I'll still count my digits after the decimal point, but this time with 2 decimal factors, I'll have 1 digit after the decimal point in each of those numbers. Now I'll multiply just like I normally would. So that means I'm going to pretend that this is 24 times 18. So I'll solve 20 times 10, 10 times 4, 20 times 8, and then 4 times 8. I'll add all of those pieces together, which tells me if I was multiplying 24 times 18, my answer would have been 432. Now I need to count those digits in parentheses. 1 plus 1 is 2, so that means my product will have 2 digits after the decimal point. So in 432, if I shift that decimal point back 2 spaces, my final product would be 4 and 32/100ths. Let's take a look at just a few more examples using the area model. So just like the traditional model is exactly the same for multiplying decimals, so is the area model or the box method for multiplying decimals. The only tiny twist we have to take is when we figure out where the decimal point goes in our answer. So if I'm multiplying 2 and 7/10ths times 9, I'm going to multiply this using the area model as if there was no decimal point. And then at the end, I'll keep track of where the decimal point needs to go. So I'm first going to start still with drawing a rectangle in the center of my paper. I'll still use my factor of 9 on the outside. I'll still split this into 2 boxes. But I'm going to pretend like this is the number 27. I don't want to pretend it's 2 and 7/10. Right now I want to imagine it as 20 and 7, as if it was the whole number problem, 27 times 9. 20 times 9, I see a basic fact there. 2 times 9 is 18, so 20 times 9 is 180. And then 9 times 7 is 63. So I'll add these two pieces together, 180 plus 63. And that's going to end up giving me a total of 243. But I have to remember that my original problem wasn't 27 times 9, it was 2 and 7/10 times 9. So now I need to decide where in this number should the decimal point go. So that's where I can look back to my factors. And just like if I was doing the traditional method, I'm going to count the number of digits after the decimal point in each factor. So in 2 and 7/10, I have one digit after the decimal point. And in my factor 9, remember whole numbers have decimals on the end, so I don't have any digits after the decimal point here. Which tells me that in my final product or my final answer, I'll have one digit after the decimal point because I know I need to add those two numbers in parentheses together. So I'll move back one space, which means my final answer would be the same as 24 and 3/10. And if I think about that, that makes a lot of sense because 2 and 7/10 is almost 3. It's in between 2 and 3. So if I multiply 2 times 9, I get 18. And if I multiply 3 times 9, I get 27. So that means my answer needs to be between 18 and 27, which 24 and 3/10 is. So that's a quick check to make sure that our answer is reasonable. Let's take a look at when we have two-digit factors. So I have 15 times 2 and 4/10. So again, I'm going to pretend like this is the whole number problem, 15 times 24. So I'll draw my boxes. I'll have a 10 and a 5 and a 20 and a 4. 20 times 10 is 200. 20 times 5 is 100. 4 times 10 is 40, and 4 times 5 is 20. So now I can add together each of those pieces. 200 plus 100 plus 40 plus 20, which gives me 360. Now I need to go back and figure out where the decimal point belongs. So in my first factor, 15, I have no digits after the decimal point. In my second factor of 2 and 4/10, I have one digit after the decimal point. So that means in my final answer or my product, I'll have one digit after the decimal point, which means I'll move back from the end one space, giving me a final product of 36 and 0/10, or the whole number 36. And again, that makes sense because 2 and 4/10 is just about 2.5. So I'm multiplying by a little bit more than 2. 15 times 2 is 30. So that means my answer should be a little bit more than 30, which it is. Let's take a look at some decimal by decimal problems. So here I have 0 and 15 hundredths times 8/10. Well, I'm going to pretend that this is 15 times 8. So I'll start with an 8 on the side, 10 and 5. 10 times 8 is 80. 8 times 5 is 40. So I'll add together 80 plus 40 to get me a total of 120. So now I'm going to count back the number of digits after the decimal point in both factors. In 0 and 15 hundredths, I have two digits after the decimal point. In 8/10, I have one, which means in my final product, I should have three digits after the decimal point. So that means I need to move back 1, 2, 3 spaces for a final product of 0 and 120 thousandths. In 1 and 26 hundredths times 3 and 5 tenths, same thing, but this is going to be as if it is a 3-digit by 2-digit problem. So I will have 30 and 5, and the 1 and 26 hundredths I'm going to pretend is 126, so I'll have 100, 20, and 6. 100 times 30 is 3,000. 100 times 5 is 500. 20 times 30 is 600. 20 times 5 is 100. 6 times 30 is 180. And finally, 6 times 5 is 30. So I'll add together 3,000, 500, 600, 100, 180, and 30. Oops, and let me shift that paper up so you can all see the whole thing. Okay, so now I'm going to add together all of those numbers. 8 and 3 is 11. 5 and 6 is 11, plus 1 is 12, plus 1 is 13, plus 1 is 14. 3 and 1 is 4. I have 4,410, but I know that my problem at the start was not a whole number problem, it was a decimal problem. So counting my digits after the decimal point, I have 2 and 1, which means my product will have 3 digits after the decimal point. So that means I need to go 1, 2, 3 spaces to the left to give me a final answer of 4 and 410 thousandths. Now I want to look at one more example, and this one is a slight twist on number 1. This is 0 and 15 hundredths times 0 and 4 tenths. I'm going to set that up again very quickly. This one you might even be able to do in your head. 10 and 5. 10 times 4 is 40. 4 times 5 is 20. Add together 40 plus 20 equals 60. But I knew from my first example and from counting my digits after the decimal point here that my product is going to need 3 digits after the decimal point. Here, I only have space for 2. So if I need to move back another digit, sometimes you need to add a placeholder 0 in order to have the right number of digits after your decimal point. So that means in this particular question, when I moved back, I needed to move back 3 loops, leaving 1 open space for a final product of 0 and 60 thousandths. So just like the area model for whole number multiplication, the area model for decimal multiplication works exactly the same way. You just need to be careful to count those digits after the decimal point so that you know exactly where to place your decimal point in your final answer. Thanks for watching.